Everyone, in previous video I have taught you how to create all the nodes in a linked list and how to display all the data present in every nodes in a linked list. In this video I'll teach you how to insert a new node into a linked list. That is how to insert at the beginning of a linked list, then how to insert at the end of a linked list, then how to insert after a given position in a linked list. Now after a given position means what? The computer asks the user at what position you want to insert. If the user says position is 2 means the new node gets inserted after position 2, that is at position 3 it will insert. So let's see one by one how to insert. First let's see how to insert a new node at the beginning of a linked list. Now see, this is the given linked list which is containing two nodes having address 100 and 200. This head pointer is pointing towards the first node. Now you want to insert a new node at the beginning of a linked list. So see, what is the first step? First step is you should define the structure of a node. What is the structure of the node? It contains two parts, data part and pointer part. Data part stores the data value and pointer part stores the address of next node. That is 200 is stored here. Now see, I am defining the structure of a node in the code. See here, struct node. Now what is the structure? First is data part, and what data is stored? Integer type. Data type is integer. So I am writing here int data. Now see, what is this second part? Second part is pointer part. Now I am naming the pointer as next. See here, pointer next. Now see, this pointer is pointing to a next node which is having same structure as previous node. So what is the structure of this node? Struct node is the structure. So this node will also have struct node. So I am writing struct node here. So I have defined the structure of each node in a linked list. Now see, now next step is, that is the first step is, I should create a new node at the beginning of the linked list. Now see, the first node is here. So I should create a new node before this. So I am creating a new node. See here. So I have created a new node. See, now let's say the address of this node is 10, for example. Now see, I should access this new node. How to access this new node? For that I should create a pointer. So I am creating a pointer called new node. This is the pointer new node, and this pointer should point towards this new node. So how to point? In this pointer I should store the address of new node. The address is 10. So this pointer gets stored 10 and this pointer points towards this new node. Now see, now how many pointers you have in the linked list? Two pointers. One is head pointer which is pointing towards the first node, and the new node pointer which is pointing to the new node. So I should create these two pointers. So see here, I am creating pointer head. Now pointer head is pointing to a node which have this structure. So I am writing struct node before it. Now I have created pointer head. Now new node pointer is also there. So I am creating it, pointer new node. Now pointer new node is also having same struct node as integer and pointer part. Now see, now I have created two pointers. Now first step is I should create this new node. How to create it? By using dynamically by using malloc function. So I am creating it. See here, I am writing the code. New node equals to struct node star malloc size of node. Now see, the new node is created by using malloc function of size of node. What is the size of node? See, the data part is stored first. What is the data part? That is integer. Integer value takes 4 bytes. Then this is pointer part. This pointer part stores the address of next node. Suppose let's say 100 is stored here. So 100 is what? 100 is a integer type. So that also takes 4 bytes. So 4 plus 4, 8 bytes. So this is size of node is 8 bytes. So see here, I have created a new node. Now next step is what? You should ask the user what data he wants to insert here. So I am writing the code. See here, printf enter data. Now see, I am asking the user to enter data. Suppose the user says 7 I want to insert here. So see, how to insert 7 into this data part of new node. How to insert? See, that means 7 should be read. The user enters 7. Now the computer should read 7 as the data part of new node. How to read it? By using scanf function. So I am writing the code. See here, scanf percentage d comma new node and new node data. Now see, 7 is read as percentage d. What is that percentage d? That is new node data. New node address is 10. 10's data is data part. So you are storing 7 over here. Now you have stored the data. Now next step is what? See, now you have created a new node with data value in it. Now you should fix this as first node, because now before inserting, this head is pointing towards this node address 100, so it's considering this as first node. Now you should make this as first node. How to make? There are two steps. First two steps. One step is C. Now in this pointer part of new node, you should store the address of this first node, that is 100. I should store here. So if I store 100 here, see here, if I store 100, then it creates a link. This node will point towards this node. This is one step. Now the other step is what? See here, head is used to point towards the first node, but after inserting, head is pointing towards here, but you should point it towards this new node. So in head pointer, I should store the address of new node, that is 10. So I should modify this head as 10. So this pointer gets cancelled and head pointer will point towards this node. These are the two steps. Now see, you have inserted a new node at the beginning of a linked list. What changes you have made? You have updated the pointer part, the next pointer of new node, and you have updated head pointer. So these two changes you should make. Now which change you should make first? Which step you should do first? See, suppose I am updating head pointer first. Let's see here. Now head is pointing at 100 at starting, and this link is not pointing. So this is 0. This is at starting, it's not pointing to anything. Now see, suppose I'm updating head value first. I'm pointing head to this 10. So see how now head should store 10 value. So how to get 10 from the new node? New node has the address 10. So see here, suppose I'm updating head first. Head equals to new node. So now see, new node is 10. I'm putting 10 over here, head. So this pointer gets cancelled and this head pointer is pointing towards the first node. Now see, if I do second step as this, now I am updating this next pointer to this thing. See, now in this next pointer I am storing the address of this node. So I should store 100 over here. So see here, how I can access this pointer? By using new node next. So see here, new node next. Now see, new node next, 10's next is this pointer. In this pointer I should store 100. But where can you get 100 from? Head. You can get it from head. But see, head is updated to 10. You have updated 100 to 10. So you can't get this 100 address from anywhere. So you should not update head value first. You should update this next pointer first. So you should reverse the step. See here. Now this is pointing at 100 only. Now you are updating first this thing, next pointer. So see here, I am writing new node next equals to head. Now see, what is head? Head is 100. Now 100 is put into new node next. New node is 10. 10's next is this pointer. In this pointer I am putting 100. So this link get connected. This node 10 is pointing to node 100. So this is the first step. Now next step is you should update the head pointer. Head pointer to 10. You should store 10 into this head. So see here, I am writing the code. Head equals to new node. Now see, head is this head pointer. In this pointer I should store new node address. New node is 10. So I am updating it to 10. So this pointer gets cancelled. And this head pointer is pointing towards this node, new node. Now see, now you have inserted the new node at the beginning of a linked list. This is how you should, and also I have written the code for it. This is how you should insert the new node at the beginning of a linked list. Now see, now I will teach you how to insert a new node at the end of a linked list. End means, see at here, this is the last linked list, last node. Now you want to insert here. So see here, what you have to do. See, first I should define the structure of each node. So I have defined here int data value and next pointer. Now see, next step is I want to create a new node. So I have created a new node. Now see, now I need to access that new node. How I can access? By using a pointer called new node. So I'm creating a pointer called new node. Now see this. Now let's say the address of this node is 300. So this new node pointer should store 300. Then only this pointer points towards this node. Now see. Now I have created a new node pointer. Now see how many pointers are there. Two pointers, head pointer and new node pointer. So I should write it and in the code I should create that two pointers. So I am creating, see, pointer head. Now pointer head is pointing towards a structure. So I am writing struct node before it. And another pointer is new node pointer. That pointer is also pointing towards a structure node. That is struct node. So I am writing struct node here, then pointer new node. Now see, I have created two pointers. Then see, for the first step is I should create this new node. How to create? By using dynamically, by using malloc function. So I am writing the code. See, new node equals to struct node star malloc size of node. Now I have created this new node by using malloc function, and the size of node is 4 plus 4 bytes, 8 bytes. Now see, now I have created a new node. Now I should ask the user what data he wants to store into this data value of new node. So suppose, so if the user says 8 means 8, suppose let's say 10, that means 10 should be stored in the data. So I should ask the user what data he wants to store. So I am writing the code. See here, printf enter data. Now the computer asks the user to enter data. Now if the user says 10 means 10 should be put into the data part of new node. So that means 10 should be read as new node data. So how to read? By using scanf function. So I am writing SC scanf %d comma and new node data. Now this data, enter data is 10. 10 is read as new node data. New node is 300. 300 data is data part. So you are storing 10 over here. Now see, now in this pointer part you should store 0 because this is the next pointer. Next pointer means it stores the address of next node, but there is no node after this. So you should store 0 over here. So how to access this pointer part? By using new node next. So I am writing the code here. See, new node next equals to 0. Now 300 next is 0. Now see, now I have created a node at the last, but I should fix this as last node because now before inserting this is considered as last node. The address 200 is considered as last node. Now you should make 300 as last node. How you can make? So in the pointer part of address 200, that is here, you should store the address of this node. That is 300 you should store here. Then it creates a link here. So for storing here in this pointer, you need to access this node, access the node which is having address 200. Now how you can access? There is no, for that you should need a pointer. So but there is no pointer pointing towards this node. So I am creating a pointer called temp. So I am creating the pointer temp. Now see, this temp pointer can't directly point towards this node in a linked list. In the array you can create a pointer and it can point directly, but in linked list you can't directly point towards any node. For that you should you should start from beginning of the linked list. First you should put temp equals to head. That means temp equals to 10. Head is 10. So temp should point at first node. Then one by one temp should move towards the second node, then third node, then this last node it should move. So see, first step is I am creating a pointer called temp. So see here I am writing pointer temp, which is pointing towards a struct node. Now see, now that temp is what? Temp is equals to head. It's pointing to the first node. So I am writing here temp equals to head. Now see, now temp should move one by one till this last node here, because in this node I should store the address of, in this next pointer I should store the address 300. So temp should point till here. So how I can point here? See, how I can say this is the last node? before inserting this. See, when temp next, see, when temp is here, temp is 200, then 200 next is 0. That means when this next pointer is 0, then you can say that was the last node. So see, when this is the last node, you can't move the temp pointer again. So you should stop here. That means you should move when the temp is pointing here, then you should move. Till this you should move. So see, I am writing the condition. While temp next not equals to 0. This step I am writing. See, now check whether temp next is not equals to 0. Temp is 10. 10 next is 100. It's not equals to 0. So what you are doing? You are moving the temp pointer one step forward. So how to move? So you should store 100 into this temp. So how you can get 100? From the pointer part of temp. So see here, I am writing the code. Temp equals to temp next. Now see, temp is here. You should update it to temp next. Temp is 10, 10 next is 100. So you are updating this to 10, 100. So this temp pointer is pointing towards the second node now. Now see, now again repeat the step. See, you are checking whether temp next is not equals to 0. Temp is 100, 100 next is 200. It's not equals to 0. So you enter into this condition. Temp equals to temp next. So temp is 100, 100 next is 200. So you are updating it to 200. So this pointer is pointing to the third node, which is having address 200. Now see, now again repeat the step. You are checking whether temp next is not equals to 0. Now see, temp is 200. 200 next is 0. So it does not enter into the steps. It stops here. Now see, temp is pointing towards the last node. So you have done. Now see, now in this pointer you should store the address of this node. So now how you can access this pointer? By using temp next. So I am writing here, see here. I am writing here temp next. This step is outside the bracket. See here. Now temp next is equals to new node. Now see, in this pointer I should store the address 300. So temp next, temp is 200, 200 next is this pointer. In this pointer I am storing the address new node, that is 300. So I am storing 300 here. So it creates a link here. So now now see, now you should move the temp to one step forward. So temp, you no need to do that step, but I am doing. See, now temp should point towards last node. So how you can move? I am writing the code. See, temp equals to new node. Now temp is what here? Here I should write the address, new node address. New node is 300. So this is 300. So this pointer is getting cancelled. And this 300 is pointing towards last node. Now you have inserted the node at the last. This is how you should insert a new node at the end of a linked list. Now see, now I will teach you how to insert a node after a given position. See here. Now if you should ask the user after which position you should insert the node. So I am writing the code here. See here. Print f enter position. That means it asks the user at after which position you want to insert. So if the user says, suppose let's say 5 means that 5 should be stored in position. So in position variable. So I am writing scanf functions here. Scanf %d and position. Now this 5 is stored in position. See, now this is the linked list. Now there are 4 nodes in the linked list, 1, 2, 3, 4. Now you are asking the user after which position you want to insert. If the user says 5, let's see what happens. See, there are 4 nodes only. You can insert the node till after 4th position. So you can insert till at 5th position only. But if the user says 5 means you should insert after 5th position. That means in 6th position you should insert. But there is no 5th element. If you have 5th node, then only you can insert at 6th node. So see here, in this case, number of nodes are 4. But you have entered the value greater than 4. So if you enter the value greater than number of node present here, that means if the position you have entered is greater than number of nodes, then it should print invalid. So I'm writing the condition. See here, if position greater than count. Now this count is used to count the number of nodes present here. This I have taught you in separate lecture, how to find the number of nodes present in the linked list. You should see that video first. See, now if the position greater than count, see now I have entered 5. 5 is greater than 4. So you can't insert at 6th location. So I should write print invalid. So printf invalid. Now I have printed invalid. So again I should insert other position. Suppose see. So again it asks the user to enter a correct position. So if the user says at position is 3, that means I should insert the node after 3rd position. That means at 4th position I should insert. So see here. This is first node, second node, third node. So in between here I should insert. In between third node and fourth node I should insert in between here. So see here, I have created a node, new node. Now let's say the address of this is 250, for example. Now see, for accessing this node, I should have a pointer. So I'm creating a pointer called new node. And this pointer should point towards this node. So I should store the address of this node into this. So 250 is stored here. Now this pointer is pointing to this node. Now see. Now I should ask the user to enter the data. So if the user says 7 means 7 gets inserted over here. Now see, now you have to fix this node as in between of these two nodes. That is, this is the third node. Now you should fix this as fourth node. How you can fix? See here. Then you should fix this as fifth node. Now this is fourth node. You should make this as fifth node. In between these two, you should fix this node. How to fix? So in this, you should store the address of this node. Address of this node, that is 300, in the pointer part of this node. So in the pointer part of 250, that is here, you should store the address 300. If you store 300, then it creates a link like this. So this is the previous node, this is the after node it comes. So see, now if you want to store 300 into this, how you can get 300? You can get the address 300, this 300 is stored in the pointer part of previous node, that is here. So 300 is stored here. Now to access this 300, that is this pointer part, you should know the address of this node. Now for getting the address, how you can get? You need a pointer, but no pointer is pointing to this node. So I create a pointer called temp. Now I should point the temp to this node. You can't directly point to this node. In a linked list, you should start from beginning and travel one by one. Then you should point here. So see, I am creating a pointer called temp. And this pointer should point towards the first node. That means first node address should be stored here. How I can get first node address? From head. So I should write here. See, I am writing temp equals to head. Now head is 10. So 10 is stored here. Now temp is pointing to the first node. Now see. Now I should move this temp pointer one by one. So see here, how I can move to the second node. How I can move this temp pointer to second node. That means I should store the address of second node into this. 100 I should store. From where I can get 100? From the pointer part of this node. So I am writing here, see, temp equals to temp next. Now see, temp pointer is updated to temp next. Temp is 10, 10 next is 100. So I have updated this value to 100. Now see, now this temp pointer is pointing to second node. Now see, now again you should see, now again you should move the temp pointer to next node. So again follow the same step, temp equals to temp next. So temp is 100, 100 next is 200. So here the value is updated to 200. So this pointer will point to the third node. Now see, now temp is pointing at 200. This is the updated value. So at 200, now it should stop. See why you should stop. In the user had said after position 3 you should insert. So at this place you should insert here. Now you can access this pointer by using temp. See, temp, if you write temp next, you can access this pointer. So you should stop here. So I should write a terminating condition. So see here I am writing while I less than, no, yeah, while I less than position. Now see, what is this I? I is used to store the position at which the temp is pointing. So see here, now at starting temp was pointing at 10. That means temp is pointing at first node. So I will be 1 at starting, because first node, this is temp is pointing to the first node. So I is 1. See, I am taking I is 1. Now see, now check this condition whether I is less than position. Now I is 1, 1 is less than 3. So enter into this loop. Temp equals to temp next, that is temp is moved one step forward. So temp is 10, 10 next is 100. So 100 is put over here. Then this pointer is pointing to the node 100. Now see, now again go back and check the condition whether I is less than position. Now see, you have moved to the next node. So now temp is pointing to the second node. So should increase the I value by 1, because I is pointing at 2 now. This temp is pointing at second node. So increase I by 1. So it becomes 2. So I am writing the code here. See, I plus plus. So now see, now you have moved to the second node. Now again repeat the step. Now check whether I is less than position. I is 2 here. 2 is less than 3. So you can enter into this temp equals to temp next. So move to the next node. Temp is 100, 100 next is 200. So here 200 is written. So this temp pointer is pointing to the third node. Now see, now I is increased by 1. So increase the I value by 1. Now I becomes 3. Now go back and check the condition whether I is less than position. I is 3 and position is also 3. So it's equals to position. So this condition is false. So you can't enter. So you can't move the temp pointer to next node. You are stopping temp pointer here. Now temp is pointing at 200. Now see, now you can access this node, access this pointer part from here. So see, now I have created this new node. So I am writing here by using, how you can create, by dynamically by malloc function. So I am creating here, see, new node equals to struct node star malloc size of node. Now see, I have created this new node by using malloc function. Now see, now I should ask the user to enter data. So I am writing here printf enter data. Now if the user enters 7, means 7 should be stored in the data part. How you can access data? By new node data. So I should store here, see, by using scanf function. Scanf %d and new node data. Now see, 7 is new node data, new node is 250, 250's data is here, here 7 is gets stored. Now see, now at this pointer should store, now you should fix this node as fourth node, because you should insert this node after position 3. That means in the fourth place you should insert. So in between these two nodes, so in this pointer you should store the address of this node. So address of this node is 300, 300 you should store here. How you can get 300? 300 is stored in the pointer part of this node. So how you can get the address of this node? From temp. So I am writing the code, see here. Now new node next equals to temp next. Now see, what is new node next? New node is 250. 250's next is this pointer. In this pointer I should store temp next value. Temp is 200. 200 next is 300. 300 is stored here. So it creates a link like this. Now see, now I have created a forward link. Now this node should point to this node. Now this pointer part of 200 should point to the node 250. So I should store 250 in this pointer. So how I can access 250? From new node. So I am writing that code, see here. Temp next equals to new node. Now see, what is temp next? Temp is 200. 200 next is this pointer. In this pointer I should store new node address. New node is 250. So 250 is stored here. So this link get cancelled and this pointer is pointing to this node. So see, you have inserted this data after position 3. So 1, 2, 3, 4. In fourth position you have inserted. This is how you should insert the node after a given position. And that's all for today, and thank you. If you feel my teaching is good, then like my video. And if you have any doubts or if you want to give any suggestion, then comment on my video and share my video. And don't forget to subscribe my video. Thank you.